Hypervelocity stars, upon first glance, appear like any other twinkling point of light in the vast expanse of the night sky. They seem like one of the billions of stars scattered across the universe. But if you shift your gaze away for just a second and then look back, you might be in for a surprise. The star could seemingly disappear from view. This is because hypervelocity stars travel at such tremendous speeds that their motion can deceive the human eye. These aren't ordinary stars. They belong to a newly discovered and astonishing class of stars known as hypervelocity stars. Astronomers have identified about a dozen of these stellar speedsters, and their velocities are so extreme that they could one day break free from the gravitational grip of the Milky Way galaxy, embarking on an incredible intergalactic journey. Typically, stars within the Milky Way move in predictable patterns, weaving in and out of the galaxy's spiral arms like cars zipping through city streets during rush hour. When we look up at the night sky, it's easy to assume that stars are stationary, just like the monumental pyramids of Egypt, standing still in the cosmic landscape. However, among the 200 to 400 billion stars that call the Milky Way their home, a rare and extraordinary few behave in ways that challenge our understanding of stellar motion. These are the hypervelocity stars, which stand out because gravitational interactions have accelerated them to unimaginable speeds. In fact, these stars move so fast that some can travel at speeds 2 to 3 times faster than our Sun. These stars aren't just anomalies, they're stars bound to escape the gravitational clutches of the Milky Way, hurling themselves into the vast unknown. The speed at which these hypervelocity stars travel is nothing short of extraordinary. Some have been clocked at more than 700,000 miles per hour. To put that into perspective, a hypervelocity star could cover the distance from the Moon to the Earth in a mere 20 minutes. They are solitary travelers, different from most other stars. The first hypervelocity stars discovered were large, blue giants, and they appeared to originate from the center of the Milky Way galaxy. However, the more recently discovered hypervelocity stars are quite small, not much larger than our Sun, and they don't seem to come from the galactic core. Instead, many of these stars are observed fleeing from youthful star clusters, racing away at astonishing speeds. Interestingly, most hypervelocity stars are located in the outer halo of the Milky Way galaxy, about 150,000 light-years away from the galactic center. This region is far from the densely packed core of the galaxy, and finding such fast-moving stars in this area is surprising. Their existence was actually predicted as early as 1988 by an astronomer working at the Los Alamos National Laboratory in New Mexico. Yet, it wasn't until 2005 that scientists were able to confirm their existence. The first hypervelocity star ever discovered was a staggering 350,000 light-years away from the core of the Milky Way, moving away from the center of the galaxy at an astonishing 1.5 million miles per hour. So, how does a star achieve such incredible speeds? It's extremely difficult to hurl a star out of the galaxy, and one of the most common mechanisms is an interaction with a supermassive black hole. The prime suspect for these stellar slingshots is Sagittarius A, the supermassive black hole located at the center of the Milky Way. This black hole is estimated to have a mass equivalent to 4 million suns, giving it the gravitational power needed to accelerate stars to such high velocities. For a star to escape the Milky Way's gravity, it needs to reach escape velocity, which requires a powerful gravitational kick of more than 1 million miles per hour. When a binary star system, two stars gravitationally bound to each other, passes too close to a supermassive black hole, one of the stars may be drawn inward while the other is flung outward at immense speeds. This process is known as a three-body exchange, and it's one of the leading explanations for the formation of hypervelocity stars. Astronomers have already discovered 18 giant hypervelocity stars that may have been ejected from the galactic core through this mechanism. There's also a theory that hypervelocity stars could be flung from dense star clusters through the force of a supernova explosion. In these scenarios, one star in a binary system explodes as a supernova, sending the companion star hurtling through space at an incredible speed. What's interesting about hypervelocity stars is that their composition closely resembles that of regular stars. This suggests that they weren't born in exotic or unusual environments, like the far outer reaches of the galaxy. The outer halo of the Milky Way, for example, is a sparsely populated region filled with old, low-mass stars, and it's unlikely that hypervelocity stars originate from such a lifeless area. Nevertheless, their exact origins remain a mystery, and they continue to puzzle astronomers. But hypervelocity stars are not the only strange stellar objects wandering through space. In 2017, astronomers spotted another bizarre star, one that was moving out of the Milky Way at an even more staggering speed of 2 million miles per hour, nearly 4 times faster than the Sun's orbit around the center of the galaxy. What made this discovery even more perplexing was the fact that the star, named LP 40-365, was moving against the direction in which most stars orbit the galactic center. Further analysis revealed that this wandering star was composed of heavy metallic atoms, a stark contrast to the lighter elements found in most stars. LP 40-365 isn't just a hypervelocity star, it's believed to be the remnants of a star that survived a catastrophic event, a supernova explosion. Rather than being a whole star, LP 40-365 is thought to be a piece of stellar debris, or star shrapnel, that was blasted into interstellar space by the powerful explosion. This star fragment rotates on its axis and brightens and dims every 8.9 hours, possibly due to the uneven surface of the object. It's believed that LP 40-365 has witnessed one of the most violent events in the cosmos, and it has survived, albeit as a broken remnant of its former self. Another fascinating star is Fomalhaut, also known as the Eye of Sauron because of its unsettling appearance when viewed through a telescope. Fomalhaut is more than twice the mass of our Sun and is located 25 light-years away from Earth, which is relatively close in astronomical terms. It's surrounded by a ring of dust and debris, making it look like a giant, menacing eye staring out into the universe. This star's eerie appearance has captured the attention of astronomers and stargazers alike. Then there's Vega, one of the brightest stars in the night sky and the 5th brightest star visible from Earth. Vega is a peculiar star that, upon closer inspection, reveals some surprising characteristics. For starters, Vega is not perfectly spherical like most stars. Its shape is more elongated, resembling an egg, due to its rapid rotation. Vega spins at 93% of the maximum speed that a star of its size can handle, causing its surface to bulge out at the equator. This high rotation speed also leads to temperature variations across Vega's surface, with the poles being much hotter than the equator. If Vega's rotation were any faster, it might begin to tear itself apart, a fate that could befall it in the distant future. Another intriguing star system is Mira, a binary star system consisting of a red giant and a white dwarf. Mira is known for its unpredictable dimming and brightening, caused by the red giant shedding its outer layers of gas and dust, which form clouds around the system. This material creates a comet-like tail, making Mira one of the most unique and visually striking systems in the night sky. In the vast, mysterious universe, stars can be far more complex and unpredictable than they seem from Earth. Astronomers continue to uncover new phenomena, deepening our understanding of these celestial objects and the forces that shape them. For more discoveries and the latest in cosmic mysteries, stay tuned to Waves Discovery as we continue to explore the fascinating wonders of the universe.